let's continue with our implementation of finding fixed points of functions in Python and Perl. We stopped at the approximation of the golden ratio. And as we have shown previously, the golden ratio is a fixed point of the average damp of the function lambda x 1 plus 1 over x. Okay, and again, 1 can be taken as the first guess. Okay, so let's take a look at on the Perl side. So we can define the golden ratio lambda, which will return the anonymous subroutine equivalent of lambda x 1 plus x. And this is Perl's equivalent of lambda x 1 plus x. Okay, looks good. Okay, back to Python. Just trying to align the code. Now we can start approximating. This is our first approximation function that approximates square root of n, and this is equivalent in Perl as a fixed square root of n is a fixed point of the average damp of lambda x n over x. Okay, now we can do the same thing, port the same thing into the Perl file. So this is the average damp of the square root of lambda of the first argument, and the square root of lambda of n, the scalar n, returns if we go up, we can see what it returns. It returns this anonymous function, well, essentially Perl's equivalent of lambda x n over x. Oops, I deleted something that I shouldn't have. Okay, I'll go back. Where was I? Yes, right here. Okay. Okay, so this is what this returns: square root of lambda. This is equivalent, except that it cuts out one level of indirection through the call to the square root of lambda. We can simply inline the generation of an anonymous function in Perl, as we did in Python. So, well, in Python there's no need to define square root of 0 to. We could, but we don't have to. Okay. Let's align square root of 1. So this is the find fixed point of the average damp of lambda x n over x squared, and we can cubic root, right? And then a cubic root of 0, 1. Cubic root 0, 1. That's the same except that cubic root lambda returns this anonymous function right here, a Perl's equivalent of the lambda function. Okay, so this is what cubic root lambda returns. Okay, and then this is the equivalent of cubic root 0, 1, which cuts out the call to cubic root lambda in Perl. Okay, and this is cubic root 03, which calls ith root lambda, and in Perl this call to ith root lambda on n, and 3 returns, let's go up where we defined it, that generic formula, the subroutine that implements the generic formula, and yeah, this is where it is, and it returns this subroutine. Let's cut it out and paste it into the comments. That's right over here. Okay. And if I is equal to 3, then we're going to return this. Okay. And 1 is the first guess. Okay, so let's go to the golden ratio. Let's call it the function the golden ratio because it's a unique number. So the golden ratio is a fixed point of the average damp of lambda x 1 plus 1 over x, with 1 being the initial guess. And the golden ratio lambda is the function that subroutine that returns another subroutine, which is the equivalent of lambda x1 plus 1 over x. Okay, this is the function. This is what it returns. Golden ratio lambda. Okay, and then we can, yes, that's the function that returns another anonymous function. And let's implement it without the call to golden ratio lambda. So instead of calling this, we just inline the construction of an anonymous subroutine. Okay, And then we're going to test that calls to our approximation of square roots and cubic roots and the golden ratio and Perl and Python calls. So this is what this is our square root, square root, square root, and this is what Perl will return as native. Perl calls this cubic roots, and it's Perl's equivalents, and these are two calls to our golden ratio approximation functions in Perl. Okay, let's go to the command line and test both implementations. Okay, so Python fixed point.py. So the first two values is hours. The third value is what Python computes. This is the square root of 2. And then this is our two values for the square root of 3. And then the third value is Python's. Right, and then the third, the next line is, okay, that's the square root of 9. Okay, then this is the cubic root of 2, the third value being Python's, and the first two are as cubic root of 3, and then the cubic root of 9, and golden ratio, that's the last value. Okay, let's see if we can cd into the directory with the Perl implementation of the same concepts. So let's run this file. Okay, and these are Perl's numbers. The first three are hours, and then the fourth is Perl's. Alright, then the last two values are the golden ratio approximations. As the square root of 3, cubic root of 2, then the cubic root of, the next line is the cubic root of 3, and then the cubic root of 9, and two approximations of the golden ratio.